This is Bob Capetta from the College of the Florida Keys, and this lesson is on parabolas. So what is a parabola? It's the set of points equidistant from a fixed point, called the focus, and a given line, called the directrix. So here's a description of that. Here's the focus, and here is the directrix. Notice this point is 9.73 units from the line and 9.73 units from the point. This point is on the parabola because it is the same distance from the line, from the directrix, as it is from the focus. And here's another one. This point is 13.93 units from the line and 13.93 units from the focus. So that point is also going to be on the parabola. So all of these points have the same distance from that focus as they have from the line. So we're going to examine parabolas with the vertex at the origin. The vertex is the lowest point in this case for sure. So the general form for an opening upward parabola is x squared equals 4ay. If it's opening downward, it's also x squared equals 4ay. It is just that a is negative. Now a is the distance from the vertex to the focus. So we're going to start with an equation. We're going to identify what a is so that we can graph it. So here's our example. X squared equals 8y. We know our equation is x squared equals 4ay. A is the distance from the vertex to the focus. We need to solve for a. 4a will equal 8. If 4a equals 8, divide both sides by 4, and we get a is 2. So a is 2. Our vertex, remember, was at the origin. So our vertex is 0, 0. It's an opening upward parabola. It's an opening upward parabola. X squared equals 4ay with a is positive, opening upward. The graph always engulfs the focus, so the focus is above. So our vertex is 0, 0. Our focus is 0, 2. Opening upward, the parabola will engulf the focus. That's going to be our perspective. Now remember that a point on the parabola is equidistant from the focus as it is from the directrix. So the vertex right now is 2 units away from the focus. So it also has to be 2 units away from the directrix. The directrix in this case will be a horizontal line 2 units away from the vertex. So the directrix will be the line y equals negative 2. So we can see that here. Here's y equals negative 2. The vertex is 2 units from the focus, and the vertex is 2 units from the directrix. The vertex is a point on the parabola. Now I want to find 2 other points on the parabola. I'm going to consider points on the line parallel to the directrix through the focus. So I want to pick 2 points on the parabola on this line. So you'll see what I said on the slide. Choose 2 points on the line y equals 2, since it goes through the focus, that are equidistant from the focus and the directrix. So here is that line. Any point on this line is 1, 2, 3, 4 units from the directrix. So I also need to have a point that is 4 units from the focus. 1, 2, 3, 4 units this way, 1, 2, 3, 4 units that way. So again, you can see it. Here's our distance of 4. Distance of 4 from the directrix to any point on that line. So I need a distance of 4 from the focus also on that line, which will put the point at 4, 0, and it'll put the point at negative 4, 0. So those will be points on my parabola. I have the vertex, I have this point, and I have that point. What I often do is I draw a line segment between those 2 points. And that line segment is called the lattice rectum. And I construct a graph from the vertex through those points. And it will look something like this. 4x squared equals 8y. Again, our standard form is x squared equals 4ay. So what we can say here is that will be our graph, an opening upwards parabola. Next up, I'm going to have x squared equals negative 12y, which is still an x squared equals 4ay, but this time it's negative. It'll be opening downward. So our shape is x squared equals 4ay, so 4a is negative 12. A is negative 3. So the focus is 3 units away in the negative direction. So my vertex at the origin at 0, 0, focus 3 units away for an opening downward parabola. The focus will be at 0, negative 3. So we need to figure out what the directrix is. Remember, the points on the parabola are equidistant from the focus and the directrix. We'll notice the focus is 3 units away, 1, 2, 3 from the vertex. So the directrix has to be 3 units away from the directrix. The directrix will be up here. It will be the line y equals 3. So we can see that. Now we want to find 2 points on a line that will be on the parabola. The focus is not on the parabola. We construct a line through the focus, and we find out which points on that line are going to be also on the parabola. They have to be equidistant from the vertex and the directrix. So indeed, choose 2 points on this line, y equals negative 3, equidistant from the focus and the directrix, the dotted green line. So I've drawn in that line y equals negative 3, and the distance from the directrix is 6. So I also need the distance from the focus to be 6. 6 over will be those 2 points. So that distance is 6. I put on the dots at 6, negative 3, negative 6, negative 3. And then I connect the line segment between those 2 dots, and that line segment gives me the lattice rectum. And now I can construct my graph from the vertex through those 2 points. And that is the graph of the equation x squared equals negative 12y. Now, we started with an opening upwards parabola, and then we went to an opening downwards parabola. I can also do opening leftward, opening rightward. Again, the vertex is at the origin. If I'm starting with y squared equals 4ax, if a is positive, it's opening to the right. If a is negative, it's opening to the left. But our process is the same. A is the distance from the vertex to the focus. So let's look at an example. Y squared equals 4x. Our shape is y squared equals 4ax. So 4a is 4 and a is 1. So our vertex is at 0, 0. Our focus will be to the right 1 unit, because this is an opening rightward parabola, and the parabola always engulfs the focus. 1 unit in the positive direction away from 0, 0. That is our focus. Now the directrix is the same distance from the vertex as the focus. It's just 1 unit away. So the directrix has to be 1 unit away from the focus. Here is our directrix. Our directrix will be the line x equals negative 1. So we'll draw that in. Now we can see the directrix. So our next thing is to find 2 points on the parabola through the line containing the focus. Now the distance from the directrix to that line is 2. 1 unit, 2 units. So I need 2 units from the focus, 2 units this way. We'll put a dot at that point, 1, 2. 2 units this way, we'll put a dot at 1, negative 2. So there are the 2 points. If I connect those 2 points, that would give me the lattice rectum. And then to draw the graph from the vertex through those 2 points to go ahead and give me the graph of the opening rightward parabola. And let's go ahead and do an opening leftward one the same way. This time y squared equals negative 10x, y squared equals 4ax. It's either opening left or right. Since it's negative, it's opening to the left. Y squared equals 4ax. So 4a is negative 10, and a is negative 10 fourths, or negative 5 halves. So the focus is negative 2.5 units away from the vertex at the origin, in the negative direction. So the vertex is 0, 0. The focus will be negative 5 halves, 0. Negative 2.5, 0 is where the focus will go. The directrix has to be that same distance away, 2.5 in this direction. So we will have a vertical line at x equals 2.5, or x equals 5 halves. So we'll go ahead and draw in that directrix. So here is the vertex, the focus, and the directrix. Our next strategy is to find a point on the line through the focus that exists on the parabola. There will be 2 points on that line that sit on the parabola. So I'm going to draw that line in. There's the line. The distance from the directrix to that line is 5. Notice a half, 1, 1.5, 2.5, 3.5, 4.5, 5. The distance between the directrix and any point on that line is 5. So if I go 5 units from the focus, 1, 2, 3, 4, 5 up here, at negative 2.5, 5 units down, 1, 2, 3, 4, 5. 5 units away from the focus as well will give me those 2 points. So with the distance of 5, we put those 2 points on again as negative 2.5, 5, negative 2.5, negative 5. So I have the vertex, I have 2 points on the parabola, I draw my graph through those 3 points, and I have it. I also have the lattice rectum line, just to help us visualize how quickly the graph is opening. So the first 4 problems that we did all had the vertex at the origin. What happens if I move the vertex? So I have x minus 3 squared equals 8 times y plus 4. X has to be 3 for this to behave like 0. Y has to be negative 4 for that to behave like 0. So the vertex is at 3, negative 4. So let's see that. Our shape, though, our shape is still x squared equals 4ay. And so x squared equals 8y is what we have here is our shape. So if that's the case, we have 4a has to be 8, has to be our multiplier. So a is 2. So our focus is 2 units away. This is an opening upward parabola. X squared equals 4ay opens upward. So the focus is 2 units above. So my focus will be at 3, negative 2. Distance from the vertex to the focus is 2, which will again put me there 2 units above. At 3, negative 2 is where the focus is. The directrix has got to be 2 units the other direction. So you'll notice this distance is 2. So we're going to drop to the other direction, 1, 2. This horizontal line will be what? Will be y equals negative 6. That's our directrix. And then the next thing we've got to do is find 2 points on the line through the focus, equidistant. So I'm going to draw in that line and try to identify which points are equidistant from the directrix. You'll notice the distance from the directrix to that line is 4. So I need 4 units this way out to 7. I need 4 units that way out to negative 1. So from this point to that point would be the lattice rectum. And then how do we graph this? Starting at the vertex, through that point, will give us the graph of the parabola. And I believe I have one more. This time we have y plus 2 squared equals negative 16 times x minus 1. This is a y squared equals 4ay. So it's opening either leftward or rightward. The fact that the multiplier is negative, it's opening to the left. Y has to be negative 2 for this to behave like 0. X has to be 1 for this to behave like 0. So our vertex is at 1, negative 2. You see that. Our shape, again, is y squared equals 4ax. But the 4a has to be negative 16 this time. So our shape is the same as the shape of y squared is negative 16x. 4a is negative 16, a is negative 4. 4 units away in the negative direction from the vertex. And this time it's opening leftward, so 4 units to the left, 1, 2, 3, 4. Puts my focus here at negative 3, negative 2. Check that. I think I have to fix that. And it is fixed. Focus negative 3, negative 2, which is here. And then we've got to find 2 points on the line through the focus that are on the parabola. Let's find our directrix first. 1, 2, 3, 4 units from the vertex to the focus. So 1, 2, 3, 4 units to the directrix. The directrix is this vertical line. Vertical line is x equals 5. So we have our directrix here, we have our vertex, we have our focus. Now find 2 points on the line through the focus that are on the parabola. The distance from the directrix to that line is 8. So I also need 8 units from the focus, 8 units this way, 8 units that way to find 2 other points on the parabola. So you can see where it's going to be, negative 3, 6, and negative 3, negative 10, 8 units away. So there are the 2 points that give me the endpoints of the lattice rectum. That's all I need to construct my graph. Start at the vertex, through that point, to go ahead and get our graph. That's the graph of y plus 2 quantity squared equals -16 times x minus 1. And that will conclude this lesson.